Section number 19 is entitled Vector Valued Functions. Suppose you are told that v of t is equal to 5ti minus 1 over t in the j direction. And you're asked to find the domain. Basically, you want to find the domain of both of those. When will they be defined? When will they not be defined? Well, you can multiply 5 by any number in the world, any number. That is, there's no restriction on t there. But which numbers can you divide 1 by? All numbers except 0. That will be your domain. Domain. T is not equal to 0. There's other ways. You can say from negative infinity to positive infinity. But don't include 0. Put an open bracket. That means don't include. Or from 0 to infinity. But don't include 0. That is from above 0 to infinity. Or you can say the real numbers minus the few values in that set bracket. In this case, just 0. Okay, so it's everything but 0. It's just like from pre-calc. We'll find the domain. Except now you kind of have two functions at one. Suppose we're asked to find the domain of r of t. Really should be r of t, not v. R for vector. R of t is equal to 3 over t minus 5i minus 4t divided by t plus 3j. The domain will be, well, you can't divide by 0, and you can't take the square root of negative numbers. We're not taking square roots, but we're dividing. The bottom is 5, the bottom is 0 when t is 5. You can't divide by 0. You can't divide by 0. That second denominator will be 0 when t is negative 3. So I won't allow that. And there is your domain. T cannot be 5 or negative 3. It can be everything else. But it can't be 5 or negative 3. Okay, go back and review domains from pre-calculus. Open up that pre-calc textbook. Here they want us to find the magnitude of r of t. Suppose r of t is sine of pi t in the I direction plus the cosine of pi t in the j direction. So the length of r of t, or just the length of r, you square the I component, you get sine squared of some angle, plus you square the j component, you get cosine squared of some angle. And since the angles are the same, sine squared of an angle, any angle, plus cosine squared of that same angle, this is 1. This is 1. If you were told that r of t was equal to the square root of ti plus 7tj, the length of r of t, actually it's the square root of that, which is the square root of 1, which is still 1. You square this, you get t, plus, you square that, you get 49t squared, square root. Here's the answer for that one. Okay, the next one is to sketch the function, to sketch R of t. Suppose that they tell you that R of t is equal to 3t in the I direction plus t minus 1 in the j direction. Parametrically speaking, this says x is 3t and y is t minus 1. Since the second one says y equals, I want to eliminate the t in the second one. Dividing by 3 on both sides from the first line tells me that x over 3 is t. Okay? So y is equal to t, which is x over 3 minus 1. It's a straight line. It's a straight line. Problem said to graph it, to sketch it. Alright? If x is 0, y is 0 minus 1 or minus 1. Right there. If x is 3, 3 over, so x is 3. 3 over 3 is 1. Take away 1 is 0. There's another point. There it is. Instructions also should say, give the orientation of the curve. That is, what happens as t gets bigger? Well, as t gets bigger, you make t bigger, x gets bigger. That is, x is going to the right. What happens to y? Well, as t gets bigger, x gets bigger. That just means I'm going that way. That's the direction where x gets bigger as I go to the right. Even if I was going down, if x is getting bigger, I'm going to the right. I know that because over here x is 1, and over here is 2, and over here is 3, and over at this point it's 4, and at this point it's 5. X is getting bigger. As t gets bigger, x gets bigger. The orientation is the way it's denoted with the arrow. We're moving that way. I mean, you can work it out. You can think about it. When t is 0, x is 3 times 0, and y is 0 minus 1. That's this point right there. Okay. Now, t is, say, 1. X is 3 times 1. Y is 1 minus 1, or 0. That's this point right here. As t got bigger, I went in that direction. I went from this point down here to that point up there. Okay. If from this point right here, when t was a 0, if when t was 1, it brought me to that point where I just put the x, then I would have put the arrow going down. Okay, that wasn't the case. Suppose that R of t is equal to ti plus 1 over tj. This is just codes. X is equal to what I is being multiplied by, and y is equal to what j is being multiplied by. Another way of writing t is x. So y is 1 over x. Y is 1 over x. Y is 1 over x. Now you're supposed to know how to graph that. 1 over x goes this way. Now, what's the orientation? T can't be 0. So let me say t is 1. When t is 1 and then say t goes to 2. What's happening? When t is 1, x is t. X is 1. And y is 1 over 1. Okay, so that's the point right here. 1, 1. Now when t gets bigger, t is now 2. Well, x is exactly what t is. And y is 1 over 2. When x is 2, there's y. Now 1 over 2. It went in that direction. Now, I'll assume that for this piece, it always goes in that direction. But what about the bottom left piece? What if, say, t is negative 5? Well, then x is whatever t is. And y is, well, y is 1 over what t is. Y is negative a fifth. Okay, let's let t get bigger. Let t be negative 4 or negative 3. Well, x is negative 4. That's enough. Actually, it doesn't matter what y is. X got bigger. Here was where, say, for argument's sake, where x is negative 5, and t got bigger. T went from negative 5 to negative 4, and it went that way. Okay, so there's your graph with the orientation. If you have different pieces, I think, so we don't need to do the y, so that was a mistake on my part. As t got bigger, the x's got bigger. So go from, put the arrow that goes from 1 to 2. That is in this direction, not in that direction. I forgot what I was going to say. I think I was going to say if there's two portions, do each one separately. That is, define the orientation. Do it separately. But if you have something like t equals x, well then as t gets bigger, so will x. Now, what if we had r of t is equal to, say, negative t plus 3tj. Negative ti plus 3tj. So we know that x is negative t and y is 3t. Multiplying both sides by negative 1, we learned that negative x is t. So instead of 3t, or 3 times t, it's 3 times negative x, or negative 3x. Y is equal to negative 3x, which happens to be a line that goes this way. Now, what's the orientation? As t gets bigger, as you make t bigger and bigger, x gets smaller. If t is negative 1, if t is 1, then x is negative 1. If t is 2, x got smaller, it's negative 2. If t is 3, x is negative 3. If t is 0, well then x is 0. If t is negative 1, then x is positive 1. If t is negative 2, well then x is positive 2. The t's are going bigger as I go down. The t's are getting bigger, but the x's are getting smaller. So as t gets bigger, we're moving in a direction that gives us smaller and smaller x's. At this point, the x is here. At this point, the x is here. At this point, the x is here. As x gets smaller and smaller, t is increasing. So that's why I just put the arrow going that way. It's not because it's going up. It's because the x's are going down, actually. So there are some times where arrows go one way and other times the arrow goes the other way. The next thing we're going to do, we're going to do limits. The limit for us in Calculus 3 is very straightforward. The limit is t goes to 3 of ti plus t squared minus 9 over t squared minus 3tj. The limit of that. Well, this just becomes two limits. The limit of the I part plus the limit of the j part. So whether you write what I'm going to write now, which is just what I said, you need to at least think it. Okay, whether you write what I just wrote or not, you need to at least think it. Okay. Always directly substitute. See how that works. That gives me 3i plus directly substitute. 3 squared is 9, minus 9 is 0. 3 squared is 9. 3 times 3 is 9. Oops, I'm getting 0 over 0. Now, in Calc 1, you were taught to factor. It probably isn't the worst way of doing this problem. But since we've learned L'Hopital's rule, we can use it. We take the derivative of the top, which is 2t, and we take the derivative of the bottom, which is 2t minus 3. So we get the original and times j. We get the original 3i plus, plug in 3. 6 over 6 minus 3 is 3j. Answer is 3i plus 2j. 6 over 3 happens to be 2. Didn't have to be, but it was. Okay, so we just take the limit of the I part plus the limit of the j part. Let's try one more limit problem. Suppose you have the limit as t goes to 0 of 1 minus cosine of t over t in the I direction plus, say, t squared in the j direction. What's the limit of that? Well, first it's the limit of the first. Well, 1 minus cosine of 0 is 1 over t, which is 0. It's 0 over 0. Well, then we have to invoke L'Hopital's rule. Because the limit is t goes to 0. The derivative of 1 minus cosine t is sine t. The derivative of the bottom is t plus the limit of the times I plus the limit of the second one. So it's just the limit of the first plus the limit of the second. Well, 0 squared is 0. So you get 0j. Okay. Now if you directly substitute 0 for the t's, the sine of 0 is 0. Divided by 0 is 0. So again, you're getting 0 over 0. Now you might recognize that from Calc 1 as that limit being 1. So that was at least a year ago. So what we do now is L'Hopital's rule. Derivative of the top divided by the derivative of the bottom, which is 1. The rule for dividing by 1 is don't do it. Plus 0j. Substituting 0. Cosine of 0 is 1. So you get 1i plus 0j. And there is finally your limit. We invoke L'Hopital's rule 2 times. It's better than in Calc 1 where we didn't have L'Hopital's rule. I remember doing this limit as t goes to 0 as a calculus student. I remember doing that one very clearly. Multiply top and bottom by their conjugate of the numerator. So here we want to determine the interval or intervals on which the vector valued function is continuous. Where is this vector continuous? We got Ti plus 1 over Tj. And we would like to know very much where this function happens to be continuous. Now it can't possibly be continuous where it's not well defined. That is, the first thing I would consider in such a problem is the domain. And it's not defined at 0. It's not defined at 0. I mean, you can, because you can't do 1 over 0. You can say x of t is t, and y of t is 1 over t, so y is equal to 1 over t, but t is x. And it's not continuous at 0. Okay, so the problem asks where is it continuous? It's continuous from negative infinity to 0 and or from 0 to infinity. Everywhere but 0. It's continuous at all x except 0. Let's look at another one. Suppose you have that r of t is ln of t I plus e to the t j. Okay, well, ln of t is continuous on its domain, that is when t is bigger than 0, and e to the t is always continuous. See if we can get this to be rectangular. Y equals e to the t. To get rid of t, remember ln is shorthand for log base of e. E to the x equals t. E to the x is t. And there's t. So y is equal to not e to the x, but e to the x. Which, by the way, is not the same. It's not the same as this, which here you can multiply the powers. It's not that. It's e to the e. No, it's e raised to the e to the x. It's something like this. It's e raised to this power. What's the power? E to the x. Now, the question might be, where is this continuous? Now, it looks to me as if e raised to the e to the x is continuous everywhere. But we know that there's a problem when t is less than 0. T cannot be less than 0. Now, the question is, does that create a problem? Is it going to create a problem that t is less than 0? Okay, so we know from here that t has to be greater than 0, and here t can be anything. You can raise e to any power. So the question is whether or not t has, if we have this constraint. One moment, please. I'm going to look up something and make sure I don't make a sloppy mistake. See, this function y equals e to the x is going to look something like that, I guess, which is continuous everywhere. The problem is right here. Can x be negative? That's where the problem comes in. Can x ever be negative? Now, if you look at ln of t, x can be any one of the values, the y values on this curve. X can go from negative infinity to positive infinity. X can be anything. Now, the real question comes now is, what do they mean when they say determine their intervals in which the vector value function is continuous? Are they talking about x values or t values? Now, what I would think is if they're asking me about r of t, where is it continuous, they want to know about t's. And the answer is t just has to be bigger than 0. T has to be bigger than 0. They ask you if they ask you where r of t is continuous, they're asking for the t values that make r of t continuous, not the x values. That's why I was a bit slow in answering that. I looked up the answer and it didn't really help much, to be honest. I had to argue it through. The next set of problems is given r of t, define r prime of t and r double prime of t, which is very simple. Because if r of t is some function of t times I plus possibly a different function of t times j, if r of t is that, then r prime of t is, well, you just take the derivative of the I component, that is f of t, plus you take the derivative of the g component times j, that is g prime of times j, g prime of t times j. So, if they tell you that r of t is 3t squared plus 4t in the I direction plus 11t to the 3/2 in the j direction, then r prime of t is straightforward. The derivative of that is 6t, the derivative of that is 4, so it's 6t plus 4, I plus multiply the 3t by 11, get 33 over 2 times t to the 1/2 in the j direction. R double prime of t is just the derivative of this vector value function, which the derivative of 6t plus 4 is 6i plus, bring down the power, multiply by the number in front, and then get t to the negative 1/2 j, which you might want to say is 6i plus 33 over 2t to the 1/2, or square root of t, j. Put this in the denominator because it has a negative exponent. Okay, nothing really advanced there. Just know that rule on the top. If you have r of t is a function of ti plus a function of tj, and r prime of t is the derivative of that function of t by the I plus the derivative of the function of t by the j component. The next one is to evaluate some integrals. The integral of 3t squared I plus 7tj dt. Basically, this is just the integral of 3t squared dt times I plus plus, because it says plus the integral of 7t dt times j. As you write that amount, you should think it. So you get 3t cubed over 3, which is just t cubed I, plus 7t squared over 2 times j. Since this is not a Calc 2 video, I'm not going to do any more integrals. You just integrate what's being multiplied by I, times that by I, integrate what's being multiplied by j, times that by j. But in a way, I will do some more integrals. Suppose they ask you to find r prime of t. Excuse me, they ask you to find r of t. And they tell you that r prime of t is 4e to the 2t in the I direction plus 3e to the t times j, and they give you an initial value. They tell you r of 0 is 2i. Okay. So, you know that if you have r prime of t, excuse me, and you integrate it, integrate both sides with respect to dt, a couple of things happen. One, the equal sign is still valid, and the integral of r prime of t dt is just r of t equals. Now remember, the integral of e to the anything times t is the same thing, e to the kt, and divide by the constant that t is being multiplied by. So you get 4 times this integral, which is e to the 2t divided by 2. And that's enough, plus c. And that's in the I direction. We'll say c1. Plus this integral. Can factor out the 3. The integral of 3 to the t is 3 to the t divided by 1 in this case, which I won't even bother to do, plus c2. There's no reason why the I and the j can't get their own constant. So, to save a little space, I will say that 2 goes into 4, 2 goes into 4, 2 times. Okay, so up to a constant, that's r of t. So let's find out what r of 0 is. On one hand, is 2 times e to the 2 times 0 plus c1 times I plus 3e to the 0 plus c2j. Cleaning it up, 2 times 0 is 0. E to the 0 is 1. 2 times 1 is 2. 2 plus c1, I, plus e to the 0 is 1. 3 times 1 is 3. Plus, not e, but rather c2. 3 plus c2 in the j direction, on one hand. On the other hand, they told me 2i. They told me 2i, which means 2i plus 0j. That is, this must be 2, 2i, and this must be 0. Well, if 2 plus something must equal 2, then that something better be 0. 2 plus 0 is 2, and the 3, no, as opposed to C, the 3 plus C sub 2 must be 0. That means C sub 2 must be negative 3. So I come back to this equation right here, and since I run out of space, I'll modify it right here. Plus C1. But C1 is 0. I won't even write plus 0. The second bracket, plus C2. But C2 is negative 3. So negative 3. And there is your answer. 2e to the 2ti plus 3e to the t minus 3j. Let me just write this more simply. Two e to the 2t I plus 3e to the t minus 3j. That's exactly what R of t is. That's exactly what R of t equals. On that note, that finishes up this section entitled Vector Valued Functions. Good luck with it.